Hello everyone! Welcome to the video lesson on Module 9 about combination notation. I hope you are ready and excited about our lesson for today. At the end of the lesson, you are expected to write the combination notation of objects of the given scenarios. Before we proceed, please answer the pretest to check your readiness in the lesson. You may pause the video while answering, then play it once you are done. Directions. Identify what is being asked in each question. Write your answer in your paper. Now check your answers. Let us have a recap on what you have learned on the previous lesson. Write the following problems in permutation notation. Number 1. Eric wanted to arrange his collection of books in a bookshelf. If he has 10 books, in how many ways can he arrange it if there are only 7 available spaces? Okay, that is the permutation of 10 taken 7 at a time. Number 2. 7 students wanted to play Spirit of the Glass during their math camp. In how many ways can they be arranged in a circle? Okay, we can write it as 7 minus 1 factorial. Remember that in circular permutation, we have the formula as n minus 1 factorial. Number 3. Bessie visited her farm in Batangas. She would like to plant 3 mahogany trees, 5 nano trees, and 4 guava trees. In how many ways can she plant the trees in a row? Okay, correct. That is the permutation of 12 taken 12 at a time. Now, let us go to our lesson. Let us have this problem. Consider the letters from the word math. How many 3-letter combinations can be formed? Before we solve the problem, let us recall the lesson wherein the arrangement is important. If the order of the letters are important, then we have the following possible arrangements. Remember that the number of arrangements that can be formed from 4 letters taken 3 at a time is denoted by this permutation notation. Following the permutation formula, we have 4 factorial divided by 4 minus 3 factorial, which is equal to 24. So, in permutation, there are 24 3-letter arrangements. How about in combination wherein the arrangement is not important? Let us have again the 24 arrangements. What have we observed in each column? Okay, looking at each column, there are 6 arrangements with the same letters. In column 1, the letters MAT are the present letters in each arrangement, while on the second column, we have the letters ATH, on the third column, MTH, and on the fourth column, MAH. If the arrangement of letters is not important, therefore, each column is considered as one arrangement or one combination. So, how many 3-letter combinations can be formed? Our answer is, there are 4 possible combinations. The number of combinations that can be formed from n objects taken r at a time is denoted by this combination notation. These are the different ways of writing the notation, and each one is read as the combination of n taken r at a time. Going back to our problem, the 4 letters in the word math represents n, and the 3 letters selected at a time represents r in the combination notation. Thus, the combination of 4 letters taken 3 at a time is denoted by any of this combination notation. Now, let us have more examples on how to write problems in combination notation. Write the following problems in combination notation. Number 1. 10 finalists are to be chosen from 30 contestants in a math inter-school competition. In how many ways can the 10 finalists be proclaimed? Okay, in order to write this in combination notation, we need to determine what is n and what is r in the problem. So our n here are the 30 contestants. And our r are the 10 finalists at a time. So substituting this in our combination notation, we have the combination of 30 taken 10 at a time. We can also write the combination notation in this way or this. Number 2. How many lines can be formed from 12 distinct points if no 3 points are collinear? What do we mean by no 3 points are collinear? Okay, it means that there are no 3 points that lie on the same line. Now, our n here are the 12 distinct points and r is equal to 2. Why 2? Because we need at least 2 points to form a line. So, writing this in combination notation, we have the combination of 12 taken 2 at a time. Let's have number 3. A photography club is made up of 8 boys and 6 girls. A committee of 7 has to be formed for the documentation of the World Teachers' Day program. In how many ways this can be done if the committee consists of letter A, 4 boys and 3 girls, letter B, at least 5 girls, letter C, at most 2 girls. Let us have letter A. So, we need to find the number of 4 boys that can be formed from 8 boys. In this event, our n is 8 and our r is 4. Writing this in combination notation, we have the combination of 8 taken 4 at a time. And the number of girls that can be formed from 6 girls. In this event, our n is 6 and our r is 3. Writing this in combination notation, we have the combination of 6 taken 3 at a time. So, what are we going to do with these 2 events? Since these 2 events must occur at the same time in order to satisfy the condition in the problem, so by fundamental principle of counting, we're going to multiply them. So we can write the problem in combination notation as the combination of 8 taken 4 at a time times the combination of 6 taken 3 at a time. Or you may write the combination notation in any of these 2 ways. Letter B. At least 5 girls. Let's review again what is being asked in the problem. A committee has to be formed with 7 members, and these members must consist of at least 5 girls. What do we mean by this? It means that the number of girls are greater than or equal to 5. So, it can be 5 or 6 girls. How about 7? No, it's not possible since there are only 6 girls in the problem. Now, let's have the solution. If there are 5 girls in a committee of 7, how many are boys? Okay, there are 2 boys. How about if there are 6 girls? How many are boys? There is only 1 boy. So as you can see, there are 2 possible ways in which a committee of 7 can be formed with at least 5 girls. Now, let us try to write 5 girls and 2 boys in combination notation. So it can be written as the combination of 6 taken 5 at a time times the combination of 8 taken 2 at a time. While 6 girls and 1 boy can be written in combination notation as the combination of 6 taken 6 at a time times the combination of 8 taken 1 at a time. Since either of these 2 ways can satisfy the condition, the number of ways is the sum of these 2 events. So, writing this problem in combination notation, we have the combination of 6 taken 5 at a time times the combination of 8 taken 2 at a time plus the combination of 6 taken 6 at a time times the combination of 8 taken 1 at a time. Or you may write the combination notation in this way. Now, let's have letter C, at most 2 girls. Again, a committee of 7 members has to be formed with at most 2 girls. So, what does it mean? It means that the number of girls are less than or equal to 2. So, if there are 2 girls in a committee of 7, how many are boys? Okay, there are 5 boys. 2 girls and 5 boys can be written in combination notation as the combination of 6 taken 2 at a time times the combination of 8 taken 5 at a time. Again, we're going to multiply the 2 events since both of these events must occur at the same time in order to satisfy the given condition. So, multiplying them will give you the number of ways that a committee can be formed with 2 girls and 5 boys. Now, what about if there is only 1 girl in a committee? How many are boys? Okay, there are 6 boys, and this can be written in combination notation as this. How about if there are no girls? Is it possible? Yes, it's possible that there are no girls in a committee. So, all of the members are boys. So, 0 girls and 7 boys can be written in combination notation as this. As you can see, there are 3 possible ways in which a committee of 7 can be formed with at most 2 girls. Again, we have 2 girls and 5 boys, or it can be 1 girl and 6 boys, or 0 girls and 7 boys. Either of these 3 ways can satisfy the condition. Therefore, the number of ways is the sum of these events. Okay, now let us have a wrap up on what we have discussed today. So, combination notation. The combination of n objects taken R at a time is denoted by any of this combination notation. And it is read as the combination of n taken R at a time. Valuing. Recall how the problems involving combinations were translated into combination notation. Cite a combination of acts you did or you will do that conforms to the standard of right behavior. Justify your answer. For our post test, you may pause the video while answering, then play it once you are done. Identify the letter of the correct answer. Now check your answers. Activities, again, you may pause the video while answering, then play it once you are done. Activity number 1. Let's practice. Determine the value of n and r in the following problems involving combination. Now check your answers. Activity number 2. Keep practicing. The following are problems involving combination. Write each problem in combination notation. Now check your answers. Activity number 3. Test yourself. Write the following problems involving combination. Write the problems in combination notation. Then check your answer. That's all for this video lesson. Thank you and keep safe everyone.